Geometric sequences with adamonlinetutoring. Here are the beginner questions, some of the easiest questions that you're likely to find on this topic. A geometric sequence is a sequence of numbers where each term is found by multiplying the previous term by a constant called the common ratio. We use the letter R to denote the common ratio, and this is the fixed number that you multiply each term by to get to the next one. And we use the letter A to denote the first term of the sequence. The use of these will be more helpful for the intermediate and advanced questions. For the beginner questions, we just need to find the next term of the geometric sequences, and we can do this by finding the term-to-term rule, which in this case would be identifying the common ratio, so what we're multiplying to get from one term to the next. We can do this by dividing 8 by 2 to give us 4, or likewise, because it's a common ratio and it will be the same multiplication all the way through, we can use any of the two consecutive terms and do 32 divided by 8 to also find the common ratio of 4, and therefore the next term will be found by doing 32 multiplied by 4, which is 128. For the second sequence, at first glance we may say that we're halving to get from one term to the next, or dividing by 2, but for a geometric sequence, the common ratio must be written as a multiplication. So instead of saying we're dividing by 2, we would say that we were timesing by 1/2. Again, this can still be found by taking 50 and dividing by the previous term 100 to give me the common ratio of 1/2, and therefore the next term would be half of 25, which is 12.5. For the third sequence, we can see the numerical value is changing as we multiply by 4 to get from one term to the next. But notice that the sign is also switching from negative to positive to negative, so that means we must be multiplying by -4 each time. My common ratio is -4, and -64 multiplied by -4 would give me positive 256. Lastly, the introduction of surds makes some geometric sequences harder to interpret. We can find the common ratio by doing 6 divided by √3, and if we rationalize the denominator by multiplying by √3 over √3, this gives us 6 √3 divided by 3, which is 2 √3. When faced with a geometric sequence which involves surds, it may be more beneficial to pick another two consecutive terms, which make this calculation easier. For example, if I took 12 √3 and divided by 6 instead, that would have got me to my common ratio of 2 √3 a lot quicker without the need to rationalize the denominator. 12 √3 multiplied by 2 √3 would give me 12 times 2, which is 24, and √3 multiplied by √3, which is 3, and 24 lots of 3 would give me a final answer of 72. On to the intermediate question with an increase in difficulty. The second term of a geometric progression is 48. Since we use A to denote the first term and R to denote the common ratio, we can represent the second term of this geometric sequence or progression by writing it as A multiplied by R to get from the first to the second term, and we know that this is equal to 48. We also know that the sixth term of the same progression is 12,288. This would be our first term multiplied by R to give me the second term, multiplied by R to give me the third term, and I could repeat this process a further 3 times, meaning I would be multiplying by R 5 times, and this can be simplified to be written as R to the power of 5, and we know that the sixth term is 12,288. I have simultaneous equations. If I do A multiplied by R to the power of 5 and divide this by A multiplied by R, the A's will cancel, and R to the power of 5 divided by R will give me R to the power of 4. Therefore, R to the power of 4 has to be the same as A times R to the power of 5, which we know is 12,288, divided by A times R, which is 48, meaning R to the power of 4 is 256. I can find the fourth root of 256, which gives me the value for R, the common ratio of 4. I could also have had an answer of -4, but since the question states that all of the terms in the progression are positive, this tells me that my common ratio must be positive rather than negative. Since I'm multiplying by 4 to get from one term to the next, I can finish this question and find the fifth term by dividing my 6th term by the common ratio of 4 to give me the previous term, and the same as my 5th term, which is 3072. On to the advanced question, one of the trickier questions that you're likely to find on this topic. Most of the trickiest questions around geometric sequences tend to involve the use of surds. The second term of a geometric sequence is 3 plus 2 root 2, and the third term, which is consecutively the one after, is 13 plus 9 root 2. I need to find the value of the common ratio of the sequence, giving our answer in the form of a plus root b, where a and b are integers. So to get from one term to the next of our geometric sequence, we must be multiplying by the common ratio. So if 3 plus 2 root 2 multiplied by r gives me 13 plus 9 root 2, I can rearrange this to find r by making it the subject and dividing both sides by 3 plus 2 root 2. Therefore r is equal to 13 plus 9 root 2 divided by 3 plus 2 root 2. This will involve simplifying by rationalizing the denominator, and I can do this by multiplying the numerator and the denominator by using the same terms in the denominator but using the inverse sign. So instead of having an addition, I would need a subtraction between the two terms. This will involve the use of double brackets since I'm multiplying an expression with two terms by another expression with two terms. 13 multiplied by 3 is 39. 13 multiplied by negative 2 root 2 is negative 26 root 2. 9 root 2 multiplied by 3, 27 root 2. And 9 root 2 multiplied by negative 2 root 2 is negative 18 lots of 2. The whole point of using the same terms with a different sign is to introduce difference of two squares, so the terms involving the surds cancel out. So because they cancel, there's no need to calculate those two, and I can just do 3 multiplied by 3, which will give me 9, and then 2 root 2 multiplied by negative 2 root 2, which is negative 4 lots of 2. My numerator will simplify to give me 3 plus 1 root 2, divided by 9 take away 8, which is 1. So therefore my final answer is 3 plus root 2. Here's a question that I've completed earlier. It appears as though I've made some mistakes. Pause the video and let's see if you can see what they are and write some corrections in the comments below.
Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.